Today we're going to begin our unit on bonding. So a chemical bond is just the force that holds two or more atoms together. We've already talked about this in such that it is the valence electrons that are involved in forming the bonds. So any atom will have between 1 and 8 valence electrons that it will try to either transfer or share in order to form a complete octet, having 8 valence electrons total, just like the noble gases. This achieves a lower energy and therefore is more stable. So the three major types of bonds we'll talk about. First one is the ionic bond. In an ionic bond, the element will completely transfer one or more electrons to another element or ion. So we're going to have positive and negative ions, and when they're oppositely charged, they'll attract to each other electrostatically. So in order to tell what types of compounds form ionic bonds, you'll see either a metal with a nonmetal or a metal with a polyatomic ion. And we already talked about this in our nomenclature section. And just some examples of metals with nonmetals. We have our table salt, sodium chloride, magnesium fluoride, copper nitrate. Anytime you see an element that is a metal or something paired with a polyatomic, you're going to have an ionic bond. Due to the nature of the force, the ionic bonds will be very strong, so they will have high melting points and boiling points. So something like salt typically exists as a solid because of these strong bonds present. Next we have covalent bonds. A covalent bond is going to share electrons, hence the covalent. That means covalence electrons. In order to tell this, we're going to have two non-metals. So for all the compounds that we named with prefixes, these are those types of bonds, covalent. We're going to have two types of covalent solids. They are either molecular or network. Going back to this, whenever we have an ionic solid, they are known as salts. So anytime you have an ionic bond, that will form a salt. That is what we call the solid that gets formed. So generically, sodium chloride is table salt, but any type of metal and non-metal combination will be referred to as a salt. Whereas with covalent, when we form that solid, we're either going to have a covalent molecule or a covalent network. So looking at the covalent networks first, I'm only going to hold you responsible for 3 of those. Those are diamond and graphite, which you see here are both different forms of carbon, just based upon the way the atoms are arranged. And then your next one is silicon dioxide or quartz. So if I ask you for a covalent network, it's going to be one of these 3 examples. These will be the only covalent networks you'll be responsible for. If it's any other covalent compound containing 2 or more nonmetals, it's going to be a covalent molecule, such as methane, phosphorus trichloride, water, oxygen, multiple nonmetals. Now the network solids are diamond, graphite, and silicon dioxide. They're going to have high melting and boiling points because those bonds are rather strong. However, the molecular solids, the covalent molecules, are going to have low melting and boiling points. Those are much weaker forces. So this is where we'll see our typical gases and liquids. So the examples I gave, methane is naturally a gas, and then water obviously is a liquid. Looking at polyatomic ions themselves, within the polyatomic ion, something like phosphate, PO4, or carbonate, CO3, you'll notice that these are multiple nonmetals. So within the polyatomic itself, these will be covalently bonded to each other, but then these will form ions that will interact with either other polyatomic ions or a metal. So we have covalent bonds between the elements within the polyatomic, but then they will ionically bond with something else. And lastly, we have a metallic bond. These are modeled as what's called a sea of mobile electrons. Essentially, metals really want to give up the electrons. They want to go down to their previous energy level. So their electrons will be very loosely held, and when you have multiple metal atoms sitting next to each other, the nuclei in the center will be positively charged, and they'll just give up their electrons, and those electrons will be free to flow from atom to atom. And this flow of electricity, or of electrons, is called electricity. So that's why all metals are referred to as being conductors, because they will conduct electricity easily because they freely give up their electrons. So in order to tell if there's a metallic bond, you will have just a metal by itself, like copper. Those copper atoms will be metallically bonded to each other, or even barium, zinc, any of the metals that are to the left-hand side of the periodic table. But it won't be a metal with anything else. It will be a single metal by itself. Metals, as you're aware, are very strong. They're typically solids, and that's because of the strong bonds between them. So the way that you'll use this information is I will give you a mixed list of compounds, and you'll have to tell me what type of bond and which type of solid. So just going through our examples, CaCl2, calcium is a metal with a nonmetal, so this is an ionic bond, and we call ionic bonds salts. So this is the type of bond, and this is the type of solid. Silicon dioxide, this was one of our examples of covalent networks, and just to abbreviate, that is a covalent network. CH4 is methane, that is a covalent. It's not one of our three network examples, so that is just a covalent molecule. Cu is copper by itself, not ionically linked with something else to make it a salt, so it is just a metallic metal. Potassium nitrate, potassium is metal linked with a polyatomic ion, so obviously that is an ionic salt. Diamond by itself, it was one of our examples of a covalent network. F2, so this is fluorine. You'll notice that there are two atoms of fluorine. So fluorine and other types of non-metal molecules, hydrogen, nitrogen, oxygen, chlorine, bromine, iodine, they're called diatomic, meaning that they're more stable in pairs, so you'll always see them with this 2 as a subscript. And since that would make it two nonmetals, it is a molecule, and it is a covalent molecule. NH4 is ammonium with hydroxide, so that is an ionic salt. Phosphorus is a nonmetal, so that is a covalent molecule, not one of our three networks. And then finally, iron by itself, metallic metal. So we'll do some more practice with this in class. Now, what decides whether a bond is ionic